Okay, so we just formed some guesses about what z equals x squared plus y squared would look like, and those were really great. Now we're going to look at z equals x plus y squared, the quantity x plus y squared, and let's see if there's anything we can say about this.
Well, normally when I see squares, I think of parabolas.
Okay, that's a good observation. When you see squares, we normally in 2 dimensions start thinking about parabola.
Because like y equals x plus 2 squared, for example, would give you a parabola.
All right.
But here it's different because you have variables, you have x, but you have another number that can change. Like for x plus 2 squared, this number is fixed, but this number can change and go up and down.
Right. Interesting, yeah. So this seems like it looks like the equation of a parabola. It's okay. You don't know about equations of parabolas, do you?
No.
So that's okay. Is there anything you can say about this? Like are there any values where you recognize you can identify a spot on our graph?
You could try z equals 1.
Okay.
So,
if z equals 1, what could we say about x plus y?
So x plus y equals 1.
X plus y equals 1, if z equals 1. Anything else?
They're x plus y in both non-integer amounts.
Well, x plus y could be 1. If z is 1, x plus y could be 1.
Yep.
X plus y could be
Minus 1.
minus 1.
Yeah.
Okay. So here's an interesting question. Let's look at x plus y equals 1 first. What does that look like? What is this equation x plus y equals 1 look like? Like
This is a line.
This is a line. Okay, what are some points on this line?
Well,
So you have x and y equal.
so you could have like x equals 1, y equals 0.
X equals 1, y equals 0 is on the line, like right there.
X equals 0, y equals 1.
X equals 0, y equals 1. And we know it's a line.
Yeah. So then you can find the line.
So that means all these points have a height of 1.
Yeah.
Okay, we also have x plus y equals minus 1. I want you to tell me a couple of points on this line. X plus y equals minus 1.
So you have minus 1, 0.
Minus 1, 0, that's right there.
And you have 0, negative 1.
0, negative 1, that's right there. So we have a line over here. So all the points on these 2 lines, how high are they?
They're 1 high.
They're 1 high. Do the points that are 1 high on this graph look like the points that were 1 high on the other graph?
No.
No.
Not at all.
What did they look like on the other graph?
The other graph, they looked like a bunch of circles.
Well, the points that were exactly 1 high.
But the points that were exactly 1 high looked like a circle.
Look like a circle. Here we've got 2 lines. Interesting, huh?
Yeah.
What else? What are some other points you can tell me?
Well, negative a half, negative a half.
Negative a half is on this line.
Yeah.
Yeah.
Well,
But
maybe
some other points. Now we know all the points on those lines. Can you tell me any other point you know on our graph? Z equals x plus y squared?
So you could have negative. No, you can't have negative half. So not on the lines.
Yeah, not on the lines. A different value of z other than 1. Try. Let's find a simple value of z.
0.
0. Okay. What would it mean if z equals 0?
So so it would be x plus y squared is 0.
X plus y squared is 0.
X plus y equals 0.
So x plus y equals 0. X plus y equals 0. What kind of equation is that?
that's also a line.
That's also a line. Can you tell me some points on this line? X plus y equals 0?
Well, you could have negative a half, a half.
Negative a half. A half. That's there. About
A half, negative a half.
a half, negative a half.
You could also have 0, 0.
0, 0.
1, negative 1.
Yeah.
So it's this line here.
And so the height of all those points are what on our graph?
0.
0.
So now I'm forming a little conjecture about what this shape is going to look like when we build it like infinitely out.
Okay.
I think it's going to be this V shape. Because we started in the center with this line here.
Uh-huh.
And we moved out to the 1. We go 2, 3, 4, everything in between.
Okay.
We move out and keep getting farther and farther away from each other.
All right.
And if my conjecture is right, then these are two very different shapes.
Ah. What do you
for each
think?
other.
It would make sense because right now we just have a line on the origin now. And we increase the value of z we have once we get farther out.
Okay.
So maybe they keep going or
All right.
maybe they come back in.
All right. So now I 3D printed these shapes today, and so
Okay.
now I'm gonna show them to you.
Cool.
Hold on a second.